Subscribe now and press the bell icon. Never miss an update.
With a dynamic output modification schema. So in this paper we are implementing Radix-4 adder, so which it operates 2 bits simultaneously. So by using a dynamic modification scheme, which is nothing but a power gating block, here we are using. So using power gating technique, so we are able to achieve accuracy configurable Radix-4 adder. That means it is configured to perform both for approximate calculations and for accurate calculations. So what is the need of approximate calculations means, for some applications such as image patterning, image recognition and machine learning, like some applications which have a tolerant to accept some amount of error. So for that we are no need to give that much input to get the complete accuracy. So for those applications, complete accuracy is not necessary. So by giving complete accuracy, to achieve complete accuracy, we are consuming more energy. So to reduce that, here we are designing accuracy configurable Radix-4 adder with a dynamic modification output scheme. So coming to the circuits, here this is a Radix-4 2-bit Radix-4 adder. This is the structure of the Radix-4 adder. This means this comes under 1 bit, which operates 2 bits simultaneously. That means AI BI and AI plus 1 BI plus 1. First suppose, and here we are given 0 1 and 0 1 like this. So here we get, so as 1 is given to the NOR input and 0 is given to this input, 0 plus 1 1, which is nothing but a output 0. Let Cin also be 0 and 0, and this is 0, and here we are also achieving 0, which is given as the input to the 0. 0 plus 0 0, and the inversion like this, it becomes 1. When one thing is 0 means, so 0 plus 1 1, the output will be 1. So the output will be 1 for this. Okay, next for this we are calculating another one, which is here as 0, which is nothing but here the input is 0, and from here also it becomes 0, and here also we are getting 0. So here the output is 0, and from here we are getting, as 1 is the input, 1 and 0, NOR means we are getting the 0 as the output, as 0 is given, and here we are also getting the 0. As 0 is given to this, we are getting the output 1. By doing this one, we are getting the sum as the 0. For the carry operation, here we are calculating the 0 inversion, which is nothing but 1, and here the input is given from the 0. Here the input is 0, which gets the output as the 0, and here also the output is 0, and as the Cin is 0, and here the output is also 0, and here also the output is also 0. Here 1 it comes, and here also it comes 0. Totally we are getting the 0 operation. So this is the operation of the Radix-4 adder. So here we are simply adding at simultaneously 2 bits. Okay, and coming to the accuracy configurable Radix-4 adder, this is the structure of the accuracy configurable Radix-4 adder. Here this is the power gating techniques for P1, G5, G6, G7, and these are the used to control elements to switch these transistors. Okay, and now we will see the operation. In this, the operation depends upon SKPP input, which switches between the accuracy results and the approximate results. Suppose here the SKP is equal to 0. Here what happens means, we have to see whether these transistors are in on condition or in off condition. Here SKPP is 0 means here this one is the on condition, which is nothing but the 1, and here 1 is given to these transistors, and as also 0 is given means here also it won't supply and it will off the transistors. And as SKP is equal to 0 means here we are getting the approximate results. So in the approximate results there is some error, and here we are also shown the outputs of the approximate outputs for every pattern of the input, and also the accurate outputs for every pattern of the inputs. And here we are also mentioned that SKPP is 1 means the 𝗙cie operates in the approximate adder. When the SKPP is 0 means the 𝗙cie operates in the accurate mode. So based on this SKPP signal, here we are considering the approximate outputs as well as the accurate outputs. So here we are getting the configuration operation of the approximate power gating techniques. Like suppose if VDD SKPP is 0 means, as SKPP is 0 means as 0 cut off this one and triggers this one comes under the on condition, and the output of this only it comes under the on condition. As we altered, as SKPP is 0 means the 𝗙cie operates in the accurate mode. As this condition is in on condition means it runs under the accurate condition itself. Okay, for suppose, and here also we can see that as SKPP is 0 means here the signal comes, and here CNN is also 0 means here this signal comes. That means when the Cin or SKPP either of the input is 0 means the G7 gate should be in the on condition. As 0 is given to this transistor will be the cutoff, and SKPP is given to this one is also cutoff, means this gate output is the ND5 signal, which is nothing but here it is also the working condition, and hence it is known as the accurate operation. Now we will see the operation of these gates for SKPP is equal to 1. So when SKPP is equal to 1 means this one triggers. So as this one triggers means here we are grounded, and the output will be the 0 even though, and it is also in off condition. Okay, by this here we are not getting the supply to this gate, so this is in off, this gate is also disabled, so here we are getting the output as a 0. So similarly here also we can see this, as SKPP is 1 means this transistor is in cutoff. Okay, and this one, from this one also we can see this, as Cin is equal to 0 means here we are disabling this one, and SKPP 1 means here this is achieving. So by this we are getting the supply, and G7 is in the running condition itself. And also when SKPP, Cin both should be one condition means this do not get supply, this gate also do not get supply, both these transistors are in off condition, and the output will be the 0, which runs in the approximate condition. Okay. And finally here we are also shown the circuit under approximate condition, under accurate condition. On the first stage, this is the accurate mode condition. Every gate should be in the working condition here itself. So in the approximate conditions there will be the temporary off condition of some logic gates here. Okay, by this we are in the approximate calculations, there is no need to turn on all the logic gates mentioned there. So by this we reduce the power consumption in the approximate mode. We can reduce the power consumption by this mode. And here we are also able to see that n bit AC area fully configurable adder. Here the first bit should be the Radix-4 adder, and the later on the bits must be the ACRA. So here this is the condition to add ACRA adder. Okay, for n bit calculation, this is the structure of the adders.